Okay, now let's review everything we've learned about inverses and logarithmic and exponential expressions and equations. Here we go. We want to solve for x. We see this as a logarithmic equation with logs on each side, but there's also 3 by itself. So let's get the logs all to one side of the equation. The left side becomes the log base 2 of x plus 3, which I'm going to write first because the other log had a negative in front of it, minus the log base 2 of x minus 4 is equal to 3. And we know that whenever there's a subtraction between two logs, we can write this as a log of a quotient. So our next line will be log base 2 of the quotient x plus 3 over x minus 4 equals the 3 on the right. We now have a single logarithm. We'd like to get this into an exponential equation by changing its form here. So we will write 2 to the third power is equal to x plus 3 over x minus 4. Now we can think of this as a proportion, right? That is 2 to the third over 1, which is 8. So 8 times the x minus 4 gives us 8x minus 32 on one side equals 1 times x plus 3, which is x plus 3 on the other side. Let's get all the x's to one side of the equation by subtracting the x off and adding the 32 onto each side. This will give us 7x is equal to 35, and therefore x is equal to 5. And that becomes our solution set to this equation, pending it being defined. Let's make sure that when we take that 5 and substitute it back in, we don't get a negative. 5 minus 4 is 1. 5 plus 3 is 8. It looks like it's going to last as our solution. Okay, let's move on to this next problem that asks us to graph this logarithmic equation. If you remember, logarithmic equations generally have this shape here. They go through the point 1, 0 as well as 1 comma base. So or base comma 1, I should say. So here we go. Our key basic values before we begin is that this graph is going to go through 1 comma 0 and it's going to go through the point 4 comma 1. That's because there's a base of 4 there. We also know that it's going to have a vertical asymptote on the y-axis, also known as x equals 0. So let's now apply the various transformations in a particular order. The first thing, if you were to substitute a value in for x, we would be subtracting 2, and that means move this graph 2 to the right. So 2 to the right tells us the 1, 0 is going to move to a 3, 0. The 4, 1 is going to move to a 6, 1, and the vertical asymptote is now going to be the equation x equals 2. After we've done that, we're going to take our logarithm and make it 3 times taller. So I'm going to write 3x tall, 3 times taller. We're going to take our y values and multiply by 3. 0 times 3 is still 0, so we still have 3 comma 0. This next one becomes 6 comma 3 because 1 times 3 is 3. Now that is not going to have an effect on the location of the vertical asymptote. We then look at that plus 1 at the end of the equation, which tells us we're going to be moving this up 1. And so our key points will be at 3 comma 1 and 6 comma 4, and that will have no impact on our vertical asymptote either. So let's start with that vertical asymptote at x equals 2. Let's graph that in. We're going to have a graph that goes through the points 3, 1, and 6, 4. So here we go. 3, 1, and 6, 4 are right there and there. And we can draw in our graph as best as we can here. And notice that it has the shape of a logarithmic graph.